Welcome to Prince Maths Clinic, the e-learning solution at your pace and time.
Good day, viewers, and welcome once again to Prince Maths Clinic. Here we have very beautiful maths challenge. We are asked to find x in the first and in the second equation. Let's go right into the solution. For the first question, we are given that log x base 7 all in bracket square minus log x cube base 7 equal to 10. What we are going to do is to substitute a particular letter for log x base 7. Why? Because I have log x base 7 here and I have log x base 7. But before we do that, we are going to first of all simplify this a bit. Because what this implies is that log x base 7 is multiplied twice minus. Now, going from the law of logarithm that says if I have log a to the power of b, the power multiplies the log, which becomes b log a. In this law, this will become 3 log x base 7. Then I'll move this 10 here. It becomes negative, equal to what? 0. Therefore, I can say so anywhere I see log x base 7, I'm going to put in p in place of log x base 7. Therefore, this becomes p squared minus, this is 3 times log x base 7. Therefore, it becomes minus 3p, then minus 10 equals to 0. Therefore, I have a quadratic equation. Open two brackets, say equal to 0. What I'm looking for here is p. Put a p here, put a p here. Two numbers that I will multiply to give me minus 10. And when I add them up, I'll get minus 3 are simply positive 2 and minus 5. Those are the two numbers, so that if I say plus 2 times minus 5, I'll get minus 10. And when I say 2 minus 5, I'll get minus 3. Hence, either of these in the bracket can be equal to 0. I can now say, therefore, p plus 2 equals to 0, or p minus 5 is equal to 0. And if p plus 2 equal to 0, therefore p will either be minus 2, or if this crosses here, this becomes 5. Then we now go back to where we said what? Let p be equal to something, which is log x base 7. Recall that we have said let p be this. Since p is either minus 2 or 5, we are going to put 5 here equals to what? Log x base 7. So from here, I want to transform this into indices. Therefore, this is the way it works. If you are converting to indices, I don't want this what? 1, this base to be here. All I just need to do is to say this 7 to the power of what? 5. So my x will become 7 to the power of what? 5. 7 to the power of 5 is equal to 16,807. That's what that value means, 7 to the power of 5. Then remember also that p is equal to minus 2 as well. We have what? Minus 2 to be equal to what? Log x base 7. And from here, using the same principle, x will become 7 to the power of minus 2. And what is 7 to the power of minus 2? 1 over 49. That is what 7 to the power of minus 2 is. Good. So this is the first method. Let's look at the second method, which is much more simpler and easy to use. In the second method, We are going to first of all simplify this by writing log x base 7 minus, then using that law that says that the power multiplies in log. This becomes 3 log x base 7. Move this 10 here, it becomes what? Minus 10, all equal to what? 0. Then this is a case of a quadratic logarithmic equation. Therefore, I can open two brackets and say equal to 0. Then what I want to look for is x, and it has a what? It is in form of log in base 7. So I'm going to put log x base 7 here, log x base 7 here. Then two numbers I will multiply that will give me minus 10, and when I add them up, I will get minus 3. Are what? Positive 2 and minus 5. So it means that either of these could be equal to 0. Therefore, if log x base 7 plus 2 equals to 0, then it means that my log x base 2 equals to negative 2. Hence, x is equals to 7 to the power of minus 2, which is 1 over 49. Or if log x base 7 minus 5 equals to 0, then what does this mean? It means that my log x base 7 is equals to 5 if this crosses over. Right? And if that is possible, it then means that therefore my x is what? 7 to the power of what? 5. Which are the same values we obtained using the first method. Now let's check to see if we are correct. Let's use the first value, which is x to the power of what? X is equal to 7 to the power of 5. So let's apply that. So if x is 7 to the power of 5, now bracket 7 to the power of 5, then it's carrying a power of 3 equal to 10. This 5 is here inside the bracket. Use it to multiply the log inside the bracket. So this becomes 5 log 7 base 7. Now all squared minus. Now, based on the laws of logarithm and indices, power of power will multiply. So this becomes log 7 base 7. Then 5 times 3 is what? 15 equal to 10. Therefore, we know that this can multiply this here, right? So this becomes 5 log 7 base 7 all squared minus 15 log 7 base 7 equal to 10. I know that when my log and my base are the same, it turns to 1. So what I have here will now be 5 squared minus, this becomes 1 again, 5, 15 times 1. Then 5 squared is 25. And 15 times 1 is 15. 25 minus 15 equals to 10. So you can see that what it means 10 equal to 10. That's the meaning. So it means we are correct. Then let me also put in what? 7 to the power of negative 2 to also see if that value is correct. This is within the bracket. This is minus 2 within the bracket. So move it, say minus 2 log 7 base 7 squared minus log. This will multiply, this becomes 7 to the power of negative 6. Let's see if it will give us 10. Now, this 7 base 7 will cancel out to become 1. So I have negative 2 here, squared, minus, this will come here. This will become minus 6 log 7 base 7. And log 7 base 7 will turn to 1. So this is as saying 16 minus, this is as good as saying minus 6 times 1. Let's see if it will give us 10. Minus 2 squared will give us 4. Then minus 6 times 1 is 6. So let me take out that one. Minus times minus is plus. So 4 plus 6 gives us what? 10. So it means that my left hand side is equal to my right hand side. So it means our values are correct. In the second question, we have that 9 to the power of x is equal to 18. And I'm going to be profiling two methods to solving this as well. 9 to the power of x is equal to 18. So the first thing to do is to what? Is to say 9 to the power of x is equal to 9 times 2. The next thing to do is to take the log of both sides. So I want to take the log of both sides. But this time I'll be taking the log of both sides in base 9. Why? Because the base here is 9. So in base 9, 9 to the power of x equals to log. In base 9, I have 9 times 2. Using the laws of logarithm, I know that this power will multiply the log. This becomes x log 9 base 9. Then, using the laws of logarithm under multiplication that have the same base, you add up the log. So this becomes log 9 base 9 plus log 2 base 9. Then, to make x stand alone, I have to divide both sides by log 9 base 9. So I have to divide each of the terms by log 9 base 9 by log 9 base 9. Log 9 base 9 here cancels out log 9 base 9. Log 9 base 9 here cancels log 9 base 9. So here I have 1, here I have 1. Simplifying further, x becomes what? 1 plus the numerator here is log 2 base 9 divided by log 9 base 9. And we know that log 9 base 9 will give us 1. Good. So therefore, I will put 1 here. And log 2 base 9 over 1 is still log 2 base 9. So my x becomes 1 plus base 9 can be expressed as 3 to the power of 2. Then the log is 2. And when a base is carrying a power, you take the inverse of that power to multiply the log. Inverse means the inverse of 2, for instance, is 1 over 2. The inverse of 1 over 2 is also 2. The inverse of 5 is 1 over 5. And the reciprocal of 1 over 5 is also 5. Therefore, using that rule, 1 plus, this becomes 1 over 2 log 2, now base 3. Therefore, we can simplify. This is the original value for what? For x. That will give us exactly 18. Any attempt to get log of 2 to base 3 multiplied by half plus 1 will give us an approximate value of 18, which is also very correct. So, going further, 1 plus half. Then log 2 base 3 from our calculator multiplied by 0.5. So, if you add 1 to this, it becomes 1.3155. That is the value for x. So, let me document that here. 1.3155. Let's look at the second method. In the second method, I'll be using the principle from the definition of logarithm that says that logarithm is a power to which a base can be raised. Therefore, 9 to the power of x transformed into logarithm becomes what? X is equals to log 18 base 9. And if you want to transform it back to indices, you just say 9 to the power of x equals to 18. That is why we say logarithm is the power to which a base can be raised. Hence, I can further simplify this by saying x is equals to log 18 is the same thing as 9 times 2. Remember, base of 9. And what does this mean? It means my log 9 base 9 plus, because when a log under multiplication have the same base, you can add the logs. And log 9 base 9 gives us 1. This is 1 plus, then log 9 2 base 9. Remember, this base can be expressed as 3 to the power of 2 base, 3 to the power of, the base is 3 to the power of 2, but log of 2. And we know that when a base is carrying a power, you multiply the log with the inverse of that power. So this becomes 1 plus 1 over 2 log 2 base 3, which we found from our calculator that log 2 base 3 multiplied by half plus 1 gives us 1.3155. Let's put approximately, right? Good. So let's test our value. So if I say 9 to the power of 1.3155, let's see what we would obtain. 9 to the power of 1.3155. You get 18.00. 18.0014 approximately, which you can approximate as 18. We are very correct. But the exact value that will give you exactly what 18 is 1 plus half log 2 base 3. Kindly subscribe to this channel if you have not done so. Click on the notification icon and share this video to your friends and loved ones. Till we meet again, bye for now.